Hello everyone, and welcome back to another GIS mathematics lecture video. And in this lecture video, I want to approach this idea of the inverse of a matrix and this matrix form of the definition of an inverse. And I want to talk about how we can go about conceptually solving for this A inverse, which is the inverse matrix of a given matrix. Okay? And so to do this, we need to keep in mind this idea of reduced row echelon form that we talked about previously. We obviously need to keep around this idea of the identity matrix, but we also need one more piece. And that's this idea of what's called augmenting a matrix or augmenting matrices. And essentially what augmenting matrices means is that if we have a matrix A and we have a matrix B, right, we can create a new matrix or an augmented matrix that is both A and B. Now, I'm going to put this in red, not multiplied. Right, this gap, the fact that next to each other, we are not multiplying A times B. This is a matrix that contains both the elements of A and the elements of B. Okay? Now, in order to do this, A and B have to have the same number of rows. Okay, so what I want to do is go through a couple of quick examples of what augmenting matrices look like. Okay, so I'm going to do it first with letters, so you see that this works for anything, and then I'm going to go through a couple of concrete examples here. Okay, so let's say we have matrix A, which is going to have 4 elements in it: A, B, C, and D. Let's say matrix B has 4 elements in it, right? They're both 2 by 2 matrices. Has elements E, F, G, and H. Okay. If we augment, right? If we augment this matrix, right? What we're going to get is we're going to get a new matrix. So this is a 2 by 2. This is a 2 by 2. Right, what we're going to get is a new matrix where we have the elements of A followed by the elements of B. Right, so you can think of this is now a 2-row by 4-column matrix. Right, you can think of augmenting a matrix is really just squishing the 2 matrices together so that you have one matrix followed by another matrix, okay? This is kind of like a join, if you will. We're joining the 2 matrices together. So we're taking this matrix, shoving it up against this matrix to create a new matrix that has twice the columns, okay? So this is generically what an augment looks like. Let's look at a specific example. Let's say that A is going to be the identity matrix for a 3 by 3 matrix. Right, this is a 3 by 3 identity matrix. And let's say that B is just a matrix it's just a random 3 by 3 matrix. We'll do 3, 7, pi, 2, negative root 2, 1, 17, 13, and a third. Why not? Right? It doesn't matter what the numbers are. Right? As long as they share the same number of rows, right, we can augment. Right? And we can augment this matrix. So A will go first, 1, 0, 0, 0, 1, 0, 0, 0, 1, and then 3, 7, pi, 2, root 2, 1, 17, 13, and a third. Right, again, all I did was take A and B, smash them together so that we have the matrix that was A and the matrix that was B in a single matrix. Okay. Let's do one more example just to make sure that we really understand this process of augmentation. It's pretty straightforward, but this is going to be really important in addressing that idea of an inverse matrix. So let's do one final one. Let's do A as a 3. Let's do a 2 by 2 again. Let's do 5 pi 7 2. And we're going to have B equal to, again, the number of rows have to match. So let's do a 2 by 3. And we'll do 3, a quarter, 7, negative a half, 2, and 6, right? And if we augment this, right, again, we take A, which is 5 pi 7 2. I'm just taking the elements from A and I'm putting them over here. And then B is 3, 1/4, 7, negative a half, 2, and 6. Right, so hopefully that makes sense. Again, augmenting is just the process of taking one matrix and shoving it onto another to create a new matrix that is a combination of both. So we have the conceptual version here, we have this larger example here, and we have this other example here. And again, it does not matter what the numbers are, as long as A and B have the same number of rows, we can augment, okay? So again, augmentation is going to be key along with the identity matrix and reduced row echelon form. So hopefully you understand these 3 key concepts. If you have any questions, please reach out. Thank you.